Hello, class 9 Aggarwal students. Welcome once again to Math is Possible. Today I am going to start a new chapter for you. Okay, it's called Logarithms. Logarithms. Now, this is actually a very simple chapter. Okay, now what is logarithms? Let me tell you. According to the definition of your book, okay, logarithms were used to make calculation easy. Okay, now were used means it's no more in use now, but that doesn't mean we don't use logarithm at all in mathematics. We need this logarithm function. This is actually, logarithm is a function. Now you students of class 9 don't know what is a function. Okay, and you all are not supposed to know what is a function also, but you all do know what is a formula, right? Like say if I give you a is equal to pi r square. So now all of you all can tell me this is the formula for the area of a circle. But if I put f of a, now this becomes a function of a which is dependent on the radius. So bigger the radius of a circle, more will be the area. Okay, depends on the radius. The bigger the radius, more will be the area. What is the area? The inside part, the flat portion, the plane. Okay, the plane of this board is called the area. The boundary is called the perimeter. So bigger the radius, longer the radius, more area. This radius will cover more area. Okay, because circle is what? Just that this point is rotating. Okay, this point is fixed and this is rotating. That's how a circle is. Alright. So that is what a function is. A function is basically a formula. So logarithm is a function, but it is not, it is a function, it is an inverse function. Inverse function means just the inverse. You don't know what is a function, so you're not supposed to know what is an inverse function. You must just know that it is an inverse function for exponents. Okay, that's all. Just know it like normally. It is an inverse function for exponents. Okay, nothing else you must know. Now logarithms were used to make calculations easy. That means that earlier there were no calculator, no computer, nothing. So they took out this logarithm to make the calculation very easy. Now how do we write log? We write log like this, log. Now you see this log. First you must have something in an exponent form. Then only you can use the log. Look, if I write a to the power n is equal to b. This is in an exponent form. And if I take log on both sides, if I write log a to the power n is equal to log b. Alright. Then I write this n in front. That's a property of log. We'll go on to that later on. N log a is equal to log b. Now take this log there and divide it. So write n log b log a. Okay. Now since there is no base over here, a log is supposed to have a base also. So I'm going to tell you this, that this is going to become log b base a. This over here, a is called the base. This number has to be there. And this is some rational number b. Okay, this is some rational number base. This is some rational number q, and this is also some rational number. This is the base or some real number, whatever it is. Okay, so this number over here, log, is called a base. Now, no matter what the base is, no matter what the base is, no matter what the base is, no matter what the base of a log is, no matter, or just write no matter what the base is. Okay. No matter what the base is, we can always take the base to be 10. Base to be 10. So if you have over here, see, there is no base. Like I have written n is equal to log b divided by log a. So you can see there is no base, but the log is supposed to have a base. So you can put base 10, doesn't matter. Okay, so you can use base 10 if the log doesn't have a base, and even if it does have a base also, you can use base 10. So suppose if I write, say, log 4 base 2. Okay, so you can write this in this way: log 4 base 10 divided by log 2 base 10. You can just put two bases to the same basis for both of them. Now let us start writing. I hope you have just understood the basic logic of log, because there is nothing to do over here, no calculation, nothing to learn over here, just to make you understand what is log. You see, it's an exponent. This is an exponent, then we use log on both sides, and how n came up. So n became log b base a. So this is the base and this is some rational number. This is also some number. Okay. Now let's go on to the properties of log. That means there are some formulae, okay, which you need to note down and you're going to use. Okay. Now CBSE students don't have this chapter, so they face a lot of problem when log comes in class 12. Okay, but then ICSE students, you all are lucky because you all know what is log, okay, from class 9. So let's start with the properties of log. Okay, means formula. Logarithms. You can write full thing. First one, you don't have to learn what type of a property. They have names: quotient law, then product law. No need to learn the names. Okay, you just start. Log m into n, say base a, can be written as log m base a plus log n base a. They are all numbers, okay, not just alphabet. In easy way, if you're supposed to write this easily, how you will write? You will write log m into n is equals to log m plus log n. Log m plus log n. So if I give you an example on this, how to give you? Say log 3 into 4, say base 10. Always have base 10. Put a base, okay, don't miss the base. Alright, so you can write this as log 3 base 10 plus log 2 base 10. So you see how they got split up? When it's multiplied, they are split up. Okay, let's go on to the second one. That is log m divided by n base a. So that is log m base a minus log n base a. Alright, simply, how would you write it? Log m divided by n can be written as log m minus log n. Later on you can put the base, no problem. Don't put no problem also. As of now, this is just rough, okay, rough writing. So then you have what? Log, say 3 by 4. How can you write that? You can write that as log 3 minus log 4. Don't put any base and all, because we are just doing some rough, okay, nothing else. Don't put any base. Let's go on to the third one. The third one is log m to the power n base a. How would you write this? The n comes in front. Log m base a. Okay, there is an, so this is the only way to write this, no other short way. Example, log say 3 to the power 2 base 10 suppose. So the 2 will come in front, and then you can write this as log 3 base 10. Now with this property I also want to include something. Say if I have log m base a into log m base a. So some of you students might think this is log m square base a, but that is wrong. This is not log m square base a. This is log m base a whole square, which is not equal to log m square base a. So these two things are not equal to each other. These two things are not equal to each other. Okay, when you have like this kind, log m base a into log m base a, same thing. So what happens, both of them are squared. Okay, and this is not equal to this because this will come in front. Okay, these two things are not equal. I want you to note this down also along with 3. Let's go on to the fourth one. Okay, fourth law. And that is, say, log m base n can be written as log m base 10 divided by log n base 10. I just showed you. Log m base n can be written as log m base 10 divided by log n base 10. Suppose you have, say, log 3 base 5. This can be written as log 3 base 10 divided by log 5 base 10. Okay, if you have something like that, you can write it that way. Let's go on to the fifth one. Not many actually. 5, 6. One I'll include of my own also. Then again, log m base n can also be written as 1 by log n base m. What happens? N goes up, m becomes the base when you do 1 by log 1 by this, and vice versa also. That implies log n base m is equals to log 1 by log m base n. Okay, the opposite also. So if I am to give you an example on this, say log 3 base 5 is equal to log, sorry, why do I do it with my finger? 1 by log 5 base 3. Okay, simple. Sixth one. Okay, let's go on to the sixth one. This is the sixth one. It's log, say, m base m will always be 1. So that means if you have, say, log 25 base 5, which can be written as log 5 square base 5, which can be written as the 2 will come in front, log 5 base 5. So log 5 base 5 is in the form of log m base m, which is actually 2 into 1, that is 2. Okay, so that's it. Okay, and the other things we don't need to write it over here. Again, this will get very long. So that's it for the formulae. Okay, let's go on and start our questions. This is it for log. There's nothing else. The other things we'll learn in the question only. Okay, there's some things that you need to just learn from the questions also. Okay, so let's start with the exercise. Aggarwal, class 9 students, log chapter. So if you have problem with log, watch it. From now on, you won't have a problem. Exercise 9.1. Exercise 9.1. Where is it? Exercise 9.1 is it? Yes. Why did the page turn on? Convert the following to log form. It says convert to log form. Means change these indices or exponents to log form. First one, very simple actually. 5 to the power 2 is given as 25. In order to change to log form, many people do it very short, but you must understand the basic concept what is happening. You have to write taking log on both sides. Taking log on both sides. So this is log 5 to the power 2 and that is log 25. Alright. So the 2 comes in front according to the property. This is log 5 is equal to log 25. Take this there. Write 2 is equal to log 25 divided by log 5. Okay, now you remember log m base n can be written as what? Log m base 10 divided by log n base 10. Okay, now since there is no log 10 base, if you wanted, you could have started with, let's multiply with log base 10. Okay, you could have, and even if you didn't start with log base 10, and if you have just done this way also, still you'll get full marks. Okay, you don't have to write base 10, you are in class 9. Understand the basic thing. Now what happens? This can go back to this, so log m base n it becomes, so that's m and the 5 is n. So what will you write? Log 25 base 5. So you see how it changes back. Both of them are equal to each other. So this will change to this and this will also change back to that. So now it's in the log form. Finished. This is your answer. Let me just match this. Exercise number 9.1. Exercise 9.1, 9.1. Yes, 2 is equal to log 25 base 5. Those of you who have the book, okay, you all can check the answer at the back. It's correct. Okay. Will not be doing simple questions. Okay, because simple questions are useless. So let's do question number part 2. Let's do part 2. Part 2 actually has an alphabet. Thus I want to do this. It's given a, nothing actually. A to the power 5 is equal to 64. Alright. So what do you have to do? Take log base 10 if you can. If you remember, write it. Don't remember, no problem. Take log 10 base 10 on both sides. Both sides. So what do you do? Log a to the power 5, that's base 10, is equals to log 64 base 10. So 5 comes in front, property of log, right? Which property? Log m to the power n base a is n log m base a. That property I have used. So this is log 64 base 10. Those of you who know what to do, okay, you will write this and you will not waste much time. Some of the teachers do it very quickly. Okay, they will just show you this is happening and that will happen. They are not wrong, they are also correct. So you can do even faster than this also. But those of you who want to understand it properly, this is the way it's done. Okay, let's go on to part 3 of question number 1. Question number 1 is only going on convert to log. This is the part 3 of 1. Exercise 9.1. It's given 7 to the power x is equal to 100. So log on both sides 7 to the power x log 100 base 10 x log 7 base 10 log 100 base 10 x is equal to log 100 base 10 divided by log 7 base 10, and I didn't check the previous answer. We'll check and tell you log 100 base 7. Alright, so let's check both these answers. The second one I remember what it was, 9.1. Yeah, 64 base a is equal to 5 and log 100 base 10 is equal to x. Yeah, it's correct, just given in the opposite way. Okay, let's do part 4. Let's do part 4. This is something different. It's given log, I'm sorry, it's given 9 to the power 0 is equal to 1, of course. So you take log on both sides. Log 9 to the power 0 is equals to log 1. So 0 is equal to what? Log 1 base 9. Simple. Let's check the answer. 9.1. Yes. Correct answer. 0 is equal to log 1 base 9. Okay. Very simple actually. All can be done the same way. So I am giving you 4 to do at home. 4 of them. Part 5 is given as 6 to the power 1 is equal to 6. Part 6 is given as 3 to the power minus 2 is equal to 1 by 9. Part 7 is given as 10 to the power minus 2 is equal to 0.01. And part 8 is given as 81 whole to the power 3 by 4 is equal to 27. Let's do this one because this has a negative power. The other 3 you can try at home. Okay. One with a negative power I have to do. Same way actually, nothing much. Part 7, right? Yeah. Part 7 is given as 10 to the power minus 2 is equal to 0.01. So if you take log both sides, 10 to the power minus 2, you have to write taking log on both sides, that you have to write. Okay, so minus 2 log 10 is equal to log 0.01. So minus 2 is equal to log 0.01 base 10. Okay, this goes there and gets divided. There you go. Part 7 is also done, and answer is correct answer, minus 2 is equal to log 0.01 base 10. Part 7 is also over. Let's go on to question number 2. It says convert to exponent form. Now from the log we have to change to exponent form. Part 5, part 6 and part 8 were not done by me. Okay. So they are easy questions. I will not do them. You can try at home. Let's go ahead and change to exponent form. Second one, it says convert to expo form, means exponent form. Convert to exponent form. First one is given as log 32 base 2 is equal to 5. Now what can you do? Look very carefully. Log 32 base 10 divided by log 2 base 10 is equal to 5. I have changed it. I can put one base for each and divide them. Take this that side. So log 32 base 10 is equal to 5 into log 2 base 10. Now what happens? This 5 goes up. Why? Because log m to the power n base a is equal to log log n into log m base a, right? N comes in front, log m base a, then again n can go back on top. This is going back up there. So this is log 32 base 10 is equal to log 2 to the power 5 base 10. You see, the simple way to make you understand this, after this what happens is the log is cancelled out from both sides. But that is not true because the log is a function. You cannot cancel out a function. Let's say y'all actually don't know, but whatever it is, forget it. If I explain now, then there is no use because I will explain these things later on. Like in class 11, you need to understand what is happening over here. The log over here and the log over here is not actually cancelling out, but you don't write it in the next step. You assume that this is cancelling out. For your class 9 students, the log here and the log here is getting cancelled out, but you will not cancel out like this in the exam. You are not supposed to take your pen and do this. If you do this, you will get 1 mark. You'll get 1 mark cut. Okay. Why? Because the log and the log is actually in mathematics, it's not getting cancelled out. Why it's not getting cancelled out? I'll just show you over here. Simple. Because log is a function. I told you first only log is a function. So if you have this log 32 base 10 is equal to log 2 to the power 5 base 10, then what happens? Both ways an anti-log is getting multiplied. Anti-log log 32 base 10 is equals to anti-log log 2 to the power 5 base 10. The anti-log and the log is getting cancelled. So what you're left with? You're just left with 32 is equal to 2 to the power 5. So the anti-log and the log gets cancelled. The log here and the log there does not get cancelled. If you do this, you will lose 1 mark. Let me tell you. You will not do this. So what will you do after this? What will you do after this? Leave the answer like this? No, of course not. You will not show anything. You will not show anything. All you will write is 32 is equal to 2 to the power 5. There you go. That's in exponent form. You will not cancel it. You will not show anything. You just write 32 is equal to 2 to the power 5. That's understood. That the anti-log and the log got cancelled out. You didn't write it. Okay, you don't have to write so much. You just write 32 is equals to 2 to the power 5. I hope you have understood. Let's do 2 more questions from here. I can see 2 very nice questions. First one is easy. I'm going to do the 6th one, the 8th one. Okay, so with a point actually, one is, and the 8th one is also nice. Let's do the 6th one and let's do the 8th one. Question 2 only is going on. First one I did. So many parts actually. 8 parts. 6th one. This is the 6th one. Log 0.001 base 10, right? Yeah, is equal to minus 3. Now you must be wondering what to do here. This already has a base 10. No problem. Just write like this: 0.001 base 10 divided by log 10 base 10. Simple. Okay, log 10 base 10 is 1. See, divided by 1 it is. Nobody writes a 1. Okay, class 9 you are in. So log 0.001 base 10 is equal to minus 3 log 10 base 10. Don't put a multiply sign, okay? Take the 3 up there. Even if you put, no problem, it's getting multiplied only. But usually we don't put. Base 10 is equal to log 10 to the power minus 3 base 10. So both ways gone away. Cancelled. Think cancelled only. You can think in your mind. They won't cut marks inside your mind. Okay, so that's your answer. And I didn't check the previous one. Didn't check this one. Previous one was, I can just write it. I think it was 32 is equals to 2 to the power 5. That was the previous answer. Let's just check both these answers to part 1 and 6. To part 32 is equals to 2 to the power 5, correct? Part 6 is also correct. Let's go on to part 8. Nice question. Part 8 of 2. Log 1 divided by a base a is equal to minus 1. Simple. Same way, log 1 divided by a base 10 divided by log a base 10 minus a. Log 1 divided by a base 10 is equals to minus, of course minus 1 nobody writes, log a base 10. You can write minus 1 if you want. Okay. Some of you will get confused. 1 by a, even if you write, no problem. Log a to the power minus 1 base 10. Even if you don't write, also not problem. Gone away? 1 by a is equals to a to the power minus 1. Of course, it is 1 by a is equal to a to the power minus 1. You see how calculation becomes easy? That's why it says logarithm is used to make calculation easy. So a to the power minus 1, 1 by a. Let's do one more question for you. And the rest I can give you to do from part 2 at home. If you want to do, of course. Let's do part 7. It's given as log 0.25 base 2 is minus 2. So log, same way, 0.25, actually you know by now what to do. Log 2 base 10 is minus 2. So this is log 0.25 base 10 minus 2 log 2 base 10. So log 0.25 base 10 is log 2 to the power minus 2 base 10. You don't have to do all the steps. Okay, 0.25 is 2 to the power minus 2. Okay, 2 to the power minus 2 means 1 by 2 to the power 2, that is 1 by 4, and 1 by 4 is 0.25. Okay, let's check the answer for you. Actually, you don't need to check the answer also, you can easily see that's the correct answer, part 7, but still, yeah, correct answer 0.25 is equals to 2 to the power minus 2. So part 7 also done. Rest you can try at home. I am giving it to you, I am writing it down there. Okay, if you want you can try these questions at home, and you don't need the answer because you can easily see that the answer is correct. That is the beauty of log. 81 base 3 is equal to 4. Do this. Then I didn't do part 3. Part 3 is log, what is that? 1 by 3 base 3 is equal to minus 1. You have to write them in exponent form, means remove the log. Log should not be there. Part 4 is log, what is that? 4 base 8 is equals to 2 by 3. Sorry. 4 base 8 is equals to 2 by 3. Log 5, part 5, sorry. Log 32 base 8, log 32 base 8 is equal to 5 by 3. Try these questions at home, okay, and you will come to know the answers. So question number 2, all paths are also over. So from the next video we will start with question number 3, okay, and we'll continue. So keep taking as much help as possible from my and your channel, Math is Possible. See you in the next video. Bye bye.